Good afternoon, students. We will first tell you what is thermodynamics. We just recall you certain part of thermodynamics because we already taught in this class just 2 or 3 classes. I first tell you that thermodynamics is the branch of science which deals with the interaction between energy and material system. That means suppose we consider a beaker. Suppose this beaker contain 2 or 3 pieces of ice. These are ice. After some time, this ice is converted into liquid. That means this beaker absorbs energy from the surrounding. As a result, the temperature, which is at 0 degree centigrade, is converted into 10 degree centigrade. That means temperature increases. It absorbs energy from the surrounding and ice is converted into water. So that there is an interaction between the system energy and the between the energy and material system. Similarly, if you put a contain a beaker, you keep it at hot hot water, suppose at 60 degree centigrade. After some time, you see that the energy is exchanged from the system to the surrounding and the temperature will comes down to the room temperature. So this is called thermodynamics, how the energy is exchanged between the between the system and the surrounding. So this is called as the thermodynamics. So thermodynamics is the branch of science which deals with the interaction between energy and material system. So there are two types of thermodynamics. Basically, whatever we taught to you is there are two types. One is the classical thermodynamics, another is the statistical thermodynamics. Whatever we teach you, that is called as the classical thermodynamics. The difference between the classical and statistical thermodynamics is that classical thermodynamics, which is based upon the four law, that means one is the zeroth law, first law, second law, and third law. That means in classical thermodynamics, we treat the system as a macroscopic. Macroscopic means that we can see. But in case of statistical thermodynamics, we consider the system as a microscopic particle that we cannot see. That means atom, molecules, ions, such type, or electrons, such type, that we cannot see. That is the difference between the classical and statistical thermodynamics. So the classical thermodynamics based upon the four law. One is zeroth law, then first law, then second law, then the third law. Zeroth law thermodynamics deals with thermal thermal equilibrium and establishes the concept of temperature that we know that the temperature of the system we cannot measure directly. That is called the temperature. The zeroth law of thermodynamics deals with thermal equilibrium. That means whatever we taught you just before, ice converted to water, hot water converted to room temperature water, that is the called thermal equilibrium. Then at the concept of temperature, we know that the temperature of the system cannot be measured directly. So in that cases, the zeroth law deals with the thermal equilibrium and the temperature concept. Similarly, the first law of thermodynamics deals with the concept of internal energy. Internal energy means that is the energy stored in a system. That means suppose this hot water, this is the beaker, this contain suppose 40 ml of hot water. That means whatever be the energy stored inside it, that is called internal energy. Then second law sets the limit of converting heat into work. Converting heat into work. That means there is a certain limit that heat is converted into work. All heat cannot be converted into work. That was the limitation of the second law. And it also tells you the principle of increase of entropy. Entropy means the amount of disorderness in a system. Amount of disorderness in a system. Suppose that disorderness means, suppose these are the atoms, these are in the order form, these are all are in the order form. That means this is only possible when the atoms are in the order form, means at only at 0 Kelvin. At 0 Kelvin this is possible. But when the temperature increases, these atoms starts to vibrate from its position. That means these atoms, suppose this is in the present in a system, so in another cases that means the atoms are vibrate and they are not in a order manner, they are moves here and there. This is called the increase of entropy. Entropy means amount of disorderness in a system. And third law of thermodynamics deals with the absolute zero entropy. That means absolute zero means at 0 Kelvin all the atoms and molecules, the entropy tends towards zero. That is called the entire classical thermodynamics deals with this four law. Then deals with the four law. Then we have to know the certain thermodynamic concept. That's like system. System means the specified part of the universe which is under experimental investigation. That means suppose we consider a test tube. In the test tube we put sulfuric acid, then we put some zinc material, then the reaction takes place. So this inside the test tube it is a system, and whatever with the present outside it, it is called surrounding, and the test tube surface that is the present outside is called the boundary. So system is the specified part of the universe. That means suppose this is my universe, then this is my system. Wherever we do some experiment and we get some results, and whatever outside present in the system, these are all are called as the surrounding. And the separation between the system and surrounding is called boundary. Then it is called boundary. Boundary may be three types. Boundary may be adiabatic. Adiabatic means the temperature, but the heat cannot flow, but it cannot conduct temperature, cannot conduct heat. Then or diathermic. Diathermic means it can conduct. Diathermic or adiabatic. Diathermic means it can conduct heat, and adiabatic means it cannot conduct heat. Then boundary may be real or imaginary. Boundary may be real boundary, just like our wall in a room. These are real boundary. It may be imaginary. We can imagine that we can imagine that this is my system and the boundary is here. So we can imagine. So boundary may be real, may be rigid, boundary may be imaginary, boundary may be adiabatic, boundary may be diathermic. Rigid, non-rigid also boundary. So we can tell that. So actually there are the four types of thermodynamic systems. The system and the entire system can be divided into four types. The system different types, four types of system. One is open system. Open system means suppose you consider, you take a beaker, then in the beaker what happens, now we put some, here is the sulfuric acid is there, we put some pieces of zinc, then the reaction takes place. In the reaction takes place when zinc reacts with sulfuric acid H2SO4, it converted to zinc sulfate plus hydrogen gas. This hydrogen gas is evolved and it moves away from the system, and zinc sulfate present in the weaker, and whatever the heat is generated, the heat also moves away from the system. So it is called as the open system. That means open system is the system which can exchange energy and matter with the surrounding. Similarly, closed system means the same. We take a beaker, then we put sulfuric acid, then we put some pieces of then zinc sulfate and hydrogen gas is evolved, but we put a lead over this beaker. Then what happens? Then the hydrogen gas, whatever it cannot escape to the surrounding. So what happens? The zinc sulfate remain, the hydrogen gas is remain, but heat can moves away from the system. So closed system is a system which cannot exchange matter but exchange energy with the surrounding. Similarly, another is the adiabatic system. Adiabatic system is a system which neither exchange energy nor matter with the surrounding. That is called the adiabatic system. So in case of adiabatic system means adiabatic adiabatic system means which can neither exchange matter nor exchange but exchange work with the surrounding. That means suppose suppose in our village there is a pond is there. Suppose sun's ray falls on it and water starts to evaporate. When the water starts to evaporate, they moves upward. When it moves upward, it undergo expansion and temperature decreases. It becomes cool. But when the water vapors are condensed to form water droplet or small ice is formed. When it comes back towards the earth, then it becomes contract and gets warmer. So this is called adiabatic system. Another is the insulated system. Insulated system is the system which can neither exchange energy nor matter with the surrounding. That means example is the thermoflux. In thermoflux, if you keep hot water or hot milk or hot tea, it remain as long as 5 or 6 hours. So it remain as hot. It is called insulated. It is called as the isolated system. So this is called the thermoflux. So difference between the adiabatic system and isolated system is that isolated system is the neither exchange energy nor matter with the surrounding, but adiabatic system also neither exchange energy nor matter with surrounding. But in adiabatic system, work can exchange with the surrounding. This is the difference between the isolated system and adiabatic system. So depending upon the phase and uniformity of composition, the system can be divided into two types. One is homogeneous system, another is heterogeneous system. Homogeneous system is the system in which what happens, it has one phase. And uniform composition throughout the system. But in case of heterogeneous system which contain more than one phase, but the number of uniformity of composition is different throughout the system. That means in case of homogeneous system, if you take example, one is the air. Air is a homogeneous system. Suppose in your room, any part of the room, wherever you take the air, it contains same amount of oxygen, nitrogen, carbon dioxide, whatever is there, same everywhere is there. So air is a homogeneous mixture. Similarly, if another is the solution. Suppose you take a beaker, suppose you have the 20 ml of water and 2 gram of sodium chloride you add. So the solution is fun. Wherever you take the solution, same amount of salt, same amount of saltiness, you get a taste. So in that cases, we tell that these are the homogeneous system because it has uniform composition and phase is one. But in case of heterogeneous system, it contains more than one phase. What is the example? Suppose this is a beaker, 3 pieces of ice. Suppose this 3 pieces of ice is one phase. Suppose in that cases we put some water. In that case, what happens? Now the temperature of ice is not equal to the temperature of the water. The temperature of ice is 0 degree centigrade, but temperature of water is 10 degree centigrade. So temperature is different. So we tell that it is a heterogeneous system. Similarly, if you take this beaker and you put some water, then put some oil. In case of oil, there are two types of system. One is water and oil. So in that case of oil, there are two phase. So the physical chemical properties of oil is not same as that of the water. So it is a two phase. System. So it is a heterogeneous system because the physical chemical property of oil is not same as that of the water. So it is a two phase. So it is a heterogeneous system. Similarly, if you take a beaker, there is suppose it is the some part of food grain, then some sand you put, some sands. Here the physical chemical property of sand is not equal to that of the food grain. So it is also more than one phase, so it is also heterogeneous system. So based upon the the phase and uniformity of composition, we can also divide the system into two types. One is homogeneous, another is the heterogeneous system. So similarly, we can tell that the property depending upon the thermodynamic property. There are two types of thermodynamic property. There are two types of thermodynamic property. One is intensive property, another is extensive property. There are two types of property, intensive property and extensive property. Intensive property means the intensive property means the property which does not depend upon the quantities of matter or size of the system, then we call that it is intensive property. It does not depend upon the quantity of matter, does not depend on the quantity or size of the system. Example is temperature. Suppose in your room the temperature is at, suppose this is summer season, 35 degree centigrade. Now you divide your room into four parts, imaginary, by giving imaginary boundary, and whatever the now the and your room is divided into four systems. All the four systems, that means suppose this is your room, the entire temperature of this room is 25 degree centigrade. Now we divide this room into four imaginary parts, and these imaginary parts is the four systems, and wherever you measure the temperature same as 25 degree centigrade, so temperature is a intensive property. Similar also pressure. So pressure in your room is 1 atmosphere. If you divide by imaginary boundary into 4 or 6 or 7 parts in your room, then the pressure is same. So temperature and pressure is also a intensive property. Similar, temperature, pressure is intensive property. Similar also melting point and boiling point. Suppose you take the water you suppose 10 ml of water you take, the when you heat this water, it starts to boil. Suppose temperature is 100 degrees centigrade. So boiling, this is the called boiling point of water. When you take 100 ml of water, 100 ml of water, you starts to boil. Immediately at 100 degrees centigrade it starts to boil. 100, but it may take some time. So 10 ml of water, if you boil, it may take 1 minute. 100 ml of water, you start to boil, suppose 10 minutes. If you take also 1 liter of water, it takes about 30 minutes. That depends upon the heat capacity. Heat capacity will differ, but boiling point will be 100 degree centigrade, because when you put it thermometer in 10 ml water, you see that at 100 degree centigrade, when it is, it starts to boil. Again in 100 ml of water, you put a thermometer, you will see that at 100 degree centigrade it starts to boil. It may take some more time, but in case of 1 liter water or 200 liter water or 2000 liter of water, same is 100 degree centigrade, it starts to boil. It may take different times. That depends upon the heat capacity. So boiling point is an intensive property. Similar also melting point is an intensive property, because it does not depend upon the quantities of matter. So specific heat, viscosity, surface tension, these are all are the density. These are all are the intensive property. Density means, suppose you take a glass of water, suppose it is 50 ml of water, you put 5 gram of sodium chloride, 5 gram of sodium chloride, then the saltiness is same. When you divide this 50 ml of water into two parts, each 25, same saltiness you get in the two test tubes. Whether you divide into four parts, the saltiness will not decrease, same saltiness. So density is the intensive property, but extensive property is the property which depends upon the quantities of matter or size of the system, that is called extensive property. Suppose volume, suppose you are in the room, whatever the volume, suppose it is the 100 100 meter cube, suppose volume is 100 meter cube. Now you divide, suppose this is my room where I living, suppose this volume is 100 meter cube. Now we divide this room to imaginary boundary I kept, imaginary boundary. Now this room is divided in two parts and its volume is 50, its volume is 50. So volume is an extensive property. Similar also volume is extensive property. Enthalpy, entropy, mass is also an extensive property, because mass means, suppose you choose 10 potato, whatever is the mass. Suppose I tell that the mass 10 potato, 10 potato, suppose the mass is 1 kg. Now this 10 potato you divide into 5 potato in each part. So 5 potato means now it is 400 gram, now it is 600 gram, because potato is not same size. So 400 gram. So when the same 10 potato we divide into 4 parts, the mass will decrease. So mass is an extensive property because it depends upon the quantities of matter. Similarly, mass, volume, enthalpy, entropy, all are internal energy, heat capacity, free energy. These are all are the extensive property. Extensive property. Similarly, also we call the state function and state variables. State function means the fundamental property which define the state of a system is called as the state function. That means, suppose we consider a beaker, we have considered 5 pieces of ice. Suppose we tell that the temperature whatever the ice is present, it is 0 degree centigrade. We know that the ice is in the solid state. Suppose we tell that after some time, after 10 minutes or 15 minutes, when you again reach here, the all ice is melt and converted into liquid state. Suppose one will tell me that the temperature of this system is now 10 degree centigrade. I think that ice is not in the solid state, that was converted into liquid state. So temperature, similar also temperature, same thing happen, pressure, same thing happen, volume and composition. These are called as the fundamental properties. Fundamental properties. So the property which define the state of the system, the property which define the state of the system, then it is called as the fundamental properties. So state functions, but state variables. So these are but pressure, volume, temperature and pressure, volume, temperature and composition. These four are called as the fundamental properties. But enthalpy, internal energy, free energy, work function, entropy. These are also called as the thermodynamic property. Both are fundamental property and thermodynamic property are called as the state function. State function, but state variable. Remember, if you do not know whatever state function or state variable, only you remember that heat and work, these two are the path function, because it depends upon the path followed. Living heat and work, whatever the property you can want to know, these are all are the state function or state variables, but heat and work are the path function, but all others are the state function. Suppose one tells that there is small change in temperature, small change in composition, small change in enthalpy, internal energy. When there is a small change in fundamental property occur, we can write du, one small change in internal energy, dH small change in enthalpy, dG small change in free energy, dt small change in temperature, similar as dP small change in pressure. When we small changes are occur in the state function or state variable, we define them, but we designated, but we denoted them as du, dh, dg, dt, dp, d. These are called derivative. But when we tell that the small change in occur in heat and work, suppose heat and work, suppose I tell that heat we measure in Q, work we measure in W. Suppose we tell that the small change in heat occur, we cannot write du, we can write del Q and we can write del W. And del W means del W del Q. Del W means small change in work. Del Q means small change in heat. So when you denoted the state function and path function, the state function is denote small change in state function by state variable denoted as d, while small change in path function is denoted as del. This is the when there is a symbol like del means you know that these are the path function. When there is a small like d means you know that these are the state functions. Sometimes the path functions may be a state function, but in that case we write d. So from the symbol you can know that d means small change occurs in state function, del means small change occurs in path functions. There is a certain path in which work and heat can be act as a state function. We will tell you later when come heat and work, when we determine, we will tell you at that time. When the state heat and work as considered as a state function, and when it is considered as a path function. Similarly, we can define the process means the thermodynamic process. The thermodynamic process is the process in which the thermodynamic system moves from one state to another state. Suppose thermodynamic system means, suppose it is a beaker, it is three or three pieces of ice. After some time, we see that this ice is melt and liquid water. So here ice is converted into water. That means it is a thermodynamic process. So that means the solid state ice is converted into liquid water. So how the ice is converted into water? Now it absorbs heat from the surrounding. When it absorbs heat from the surrounding, the temperature of the ice increases, it is converted into water. But it is a thermodynamic process. Conversion of ice into water is a thermodynamic process. Similarly, when you take a beaker and you take water and suppose you write some food grains. So when you heat this beaker, this is converted into that. We see that the food grain is completely mixed. Or suppose you take the dal in water, this completely dal is formed. It is a thermodynamic process. So this is the thermodynamic process is the process in which the state of the thermodynamic system changes from one state to the another state. It's called as the thermodynamic process. There are the different thermodynamic process. One is isothermal thermodynamic process. In isothermal process means the process which takes place at constant temperature. That means dt is equal to 0. That means there is no change in temperature. That means ice is converted into water, but temperature will remain same. That means temperature will not change. Similarly, that means dal is converted into the mixed form, but temperature will remain same. Temperature system will not change. That means isothermal process. How it will occur? Suppose this is my ice is converted into water. You know that ice is absorbs heat from the surrounding and temperature of the ice increases, it is converted into liquid water. But we tell that it is a thermodynamic process, it is a isothermal process. If the ice is converted into water, then I tell that it is a thermodynamic process. If I tell that ice is converted into water in isothermal process, that means whatever the temperature is here, the temperature is also is here. But how it is possible? That means we can change the pressure, but temperature will remain change. Temperature will remain constant, but pressure will change. When you apply the pressure, when you implicate the pressure in the ice, it is converted into the water. So that means any process in which the temperature will remain constant, it is called as the isothermal process. Similarly, in isobaric process means the pressure will remain constant. Isobaric process means the pressure will be remain constant. dp is equal to 0. That means here ice is converted into water, but it is 1 atmosphere, it is 1 atmosphere. Pressure will not change, but temperature can change. That means it absorbs temperature in the ice, it is open container. Suppose it absorbs heat from the surrounding, converted liquid water. Whatever the pressure here also pressure will remain same, but in case of isothermal, temperature will remain constant. You think that when you increase the pressure, temperature automatically increase, no doubt. But how you fix the temperature constant? That means you put a reservoir. Reservoir means which then it is a sink. That means sink is a reservoir. That means when you increase the pressure on the, suppose this is a piston, when you push the piston downward, piston will come downward, the pressure will increase and temperature automatically increase, but we keep the temperature constant. That means we put a sink here, whatever the temperature increase, the temperature will return to the sink. So sink temperature will increase, but the system's temperature will remain constant, but is converted into the iso. That means in isothermal process temperature remain constant, in isobaric process pressure remain constant. Similarly in isochoric process volume will remain constant, volume will not change. Volume is the initial state, whatever is there, final state also volume will remain same in isochoric process. So that means in this cases the piston will be fixed. That means here ice converted into water, but it temperature can increase, pressure whatever change will pressure can increase, but volume will remain constant. That means this piston is fixed, in this piston will be fixed. That means in case of isothermal process, the piston this piston should be frictionless, weightless. But in case of pressure, in case of constant pressure, pressure will be remain same, and in constant volume will remain same. That means this piston is fixed with the container. Similarly, in adiabatic process means, adiabatic process is the process without exchanging heat between the system and the surrounding. That means suppose without exchanging heat means that suppose it is a beaker you put, suppose here you put sulfuric acid, then you take zinc inside it, and we tell that without exchange of heat between the system and surrounding. System ru surrounding को heat जीवनी के surrounding ru system को heat जीवनी के system ru surrounding को heat जीवनी. That means del Q is equal to 0, but dq is equal to 0. There is no exchange of heat between the system and the surrounding. That is called the adiabatic process. So this is always, but temperature can change. Temperature bhitere बढ़ी jibo. So it is exothermic. This reaction is exothermic. Temperature increase, but this increase in temperature will not move outward. Surrounding को से exchange करिबनी के surrounding रो कौनसी heats बाहर को system भीतर को जीवनी. This is called adiabatic process. So then it is a cyclic process. Cyclic process is the process in which the system undergo number of different process, but finally returns to the initial state. That means this is the initial state. It moves here downward, moves again left, then moves again upward. Wherever is there, it comes here. That means it is called cyclic process. In cyclic process, what happens? Wherever the initial state is there, final state also is reached here. That in cyclic process, change in internal energy is 0, change in enthalpy also 0 in cyclic process. That means you go to the घर को जाइयो, घर पुणी कॉलेज को आसो, घरे जमी पढ़ुल घर को आसला इनिशियल cyclic process तुम हो गला. सो ये cyclic process रे कौन होची ना चेंज इन इंटरनल एनर्जी 0 हो, चेंज इन एंथैल्पी मध्य 0 हो. बेंग पशि आसिला हे बेंग ऐसा हो गया बाकती तो ये ना cyclic process is the process in which there is whatever the initial state, it returns to the final state. That is called cyclic. Cyclic process रे internal energy change in internal energy 0, change in enthalpy मध्य 0. ता माने जदि बुझे खबो तुमे हॉस्टल रु घर को गल, घरे बुलाबुली कल, सबआडे बुलाबुली कल, पुणी हॉस्टल आसी पहुँची जीव. हॉस्टल तुम पहुँची से तुमर माने जहाँ एनर्जी थिला घरे बुलाबुली कर हॉस्टल को पहुँची गले मध्य सेतिक एनर्जी आसियो बोली आम साइक्लिक प्रोसेस रे कहूची. डी इज इक्वल तेणु तुम घर को जाइछ पढ़ापढ़ी कर पुणी आसी हॉस्टल रे पहुँची गले सेतिक पाठपढ़ा तुम पाखे थी, पाठपढ़ा लॉस हेनी बोली साइक्लिक प्रोसेस रे कहूची. But it is not possible. We are not reversible. This is a reversible cases. We are all reversible only one ideal process. Reversible process is not possible. It is just an ideal process. Then we come to the reversible process. Reversible process is the process which takes place infinitesimal slowly after attaining the equilibrium. That means After attaining the equilibrium means, suppose this is my one system, this is my another system, and we tell that this system are in equilibrium. That means once this system 1 is equilibrium with system 2, once attain the equilibrium higala mane the infinite number of steps are required to complete the reaction, so infinite time is required. That means system 1 converted to system 2, then system 2 converted to system 1. This is reversible process. After attaining the equilibrium in the reversible process, after attaining the equilibrium, then infinite number of steps are required to complete the reaction. As infinite number of steps are required, so infinite time is required. So in order to make the reversible process or reversible process to complete, then it is infinite time is required, but it is not possible. So example is frictionless adiabatic expansion or compression, frictionless isothermal expansion and compression. Then irreversible process. Irreversible process is the process which takes place rapidly without attaining the equilibrium. So it takes place a few number of steps, 3-4 steps or 1 steps or 2 steps. So finite time is required. All natural processes are irreversible. All combustion processes irreversible. Heat flow from high temperature to low temperature is irreversible. केवल लो टेम्परेचर हाई टेम्परेचर हिट फ्लो हेनी ताने आइसटा वन्स लिक्विड वाटर कन्वर्ट हो लिक्विड वाटरटा आइस को कन्वर्ट होनी सराउंडिंग आटमोस्फियर रे तेणु all heat flow from always heat टा फ्लो हम हाई टेम्परेचर रू लो टेम्परेचर हाई टेम्परेचर रू लो टेम्परेचर को हिट सदा फ्लो हम लो टेम्परेचर हाई टेम्परेचर को हिट टा फ्लो हेनी. So all combustion processes are irreversible process. All natural process, all processes involving friction सब जाक होची irreversible. आमे चालुचे गाड़ी जाउची पृथ्वी बुलुची जहाँ भी करची सब जाक फ्रिक्शन अछि. Without friction वर्क किछि कन्वर्ट हेबनी. So all are irreversible process. हमर एनर्जी खर्च हबो. आमे ताने ई साइक्लिक प्रोसेस मु जो कहली जे तमे से दिख पाठ पढिथिलो घरे बुला बुली करी छि पुनी हॉस्टल पहुंची सब जाक पाठ जा थिबो ता नॉट पॉसिबल because it all are irreversible process. This is possible only in case of reversible, but it is not. But reversible process is preferred because working fluid delivers more work than that of the irreversible process. We will tell you when you derive the expense work done by reversible and irreversible process. The reversible process occurs in infinite number of steps, so infinite time is required. So for its completion in case of reversible process. So today we stop here. This is whatever we taught you in the thermodynamics class. We just recall you. So in the next class we will go forward from the 0th law of thermodynamics. So खुदा हाफिज ओ भगवान भलरे थाओ घरे रही थाओ बाघ बुलुची बाहर को आसला माने बाघ तुमको खाइबो बाहर को आसबनी घरे थाओ पढ़ापढ़ी कर.